In this video, let's talk about Kirchhoff's current law. The Kirchhoff's laws are extremely important for anybody who's doing any kind of circuit analysis or any circuits class, network class. So Kirchhoff's current law, this is specifically obviously referring to just the current. So let's say you have some node, that little dot, we're going to call that our node. Just know if you have multiple wires coming to it, the sum of the currents entering the node has to be zero, which makes it seem a little bit more complicated than it is. Basically, to sum that up, what goes in must go out. So why it's zero? Because if you add I1 plus I2 plus I3 plus I4 together, they're going to equal zero. But notice here, we have, let's use green for positive. So I1 is coming into the node, so it's going to have a positive sign. I2 is coming into the node, so it's going to have a positive sign. But we'll use orange for a negative. I3 is going out, and I4 is going out, so they'll both be negative. So positive I1 plus positive I2 plus negative I3 plus negative I4, that's going to equal zero. So just remember, real simple, no matter how complicated something looks, what's going into a node must come out of the node, must be the same. So if you have a total of 10 amps flowing in towards this node, you got to have 10 amps coming out. And that's it. It is that simple, and you can use that as a serious tool for any of your network problems. So with that said, let's do some practice problems. All right, so for this first one, obviously this isn't a real looking circuit, but we got two wires coming in and a wire coming out of this node. I1 and I2 are going in, I3 is going out. So just on that perspective, we should know that I1 and I2 are going to be positive and I3 is going to be negative. So let's say I1 is 2 amps, I3 is 5 amps. We got 2 amps coming in, 5 amps going out. What's I2? Okay, so it's going to be pretty straightforward because we know they have to sum to 0. So 0 is going to equal I1 plus I2 plus I3. So 0 equals 2 amps plus, we don't know, whatever I2 is, plus, and we have I3 is 5 amps, but it's hitting out of the node. So negative 5 amps. And that's the big thing. So now it's just basic algebra. Add your 5 amps over to the 0. That's going to equal 2 amps plus I2. Subtract your 2 amps over 3 amps equals I2. And that's just a real simple, easy demonstration of how KCL or Kirchhoff's current law works. Let's do something that's a little bit more involved. Let me draw a little line to separate everything here. Let's try this one. This is going to be a little bit more of a complicated puzzle. So again, if you have a node, which is where these intersections are, you got current coming to them. What comes in must come out, work at one node at a time, and it's not that bad. So I6 has two unknowns, itself and I4 coming to that node. This node has I6, I1, and I4. There's three unknowns there. That's just too much. But if we look at I1 going to this node, this is good. We have I1 coming to it, and we have 20 milliamps and 60 milliamps both going away. So we know that I1 has to be equal to 60 plus 20 milliamps, right? But we can write it out a little bit more formally. So we can say I1, it's going to it, so let's do minus 60 milliamps minus 20 milliamps. They're negative because they're going away from our reference, which is this reference right now. That's all we're focusing on. Equals 0. So I1, just add those over to the 0. So 60 plus 20 is going to be 80 equals 80 milliamps. Assuming if you're watching a video like this, that basic algebra is pretty straightforward. All right, that's one answer. Nice. Now let's try to find I5. This node is going to be pretty easy because we have two coming in, one going out, the one going out is going to be I5. So we have 20 plus 30, 20 milliamps plus 30 milliamps. And we get a little bit quicker with this. We know it's going to equal to because it's going to be negative I5, but that means we can just put it on the other side of the equal sign. So we have I5. So I5 is going to equal 50 milliamps. There's 2 of the 4 down. So we can go ahead and fill some of these in. So we know we have 80 milliamps here. Nice. And we have 50 milliamps here. Getting a little crowded there. But that's a 50 milliamps going that way with I5. So now let's look at I6. It's coming to this node here. So it's coming in. We also have 40 milliamps coming in and 30 milliamps going out. All right, so that won't be too bad. So we have positive I6, positive 40 milliamps. So it's coming in this way. And negative 30 milliamps. So it'll be minus 30 milliamps equals 0, or we can just write equals 30 milliamps because we know it would go to the other side of the equal sign, just basic arithmetic. So I6 is just going to equal 30 minus 40, which obviously is just going to be negative 10 milliamps. So now I6 will write negative 10 over here. Now here's an interesting thing. Because this is a negative 10 milliamps, it's still 10 milliamps as an absolute value in this element right here. Or in this branch, rather. But our sign is saying it's going this way and it's negative 10 in that direction, which means it's actually flowing 10 milliamps in that direction, the opposite. That's all that negative means. All right, we have 1 to go. And I believe it is I4. Okay. So we can look at this node or this node for I4. So let's do both. Let's look at this node first. So I4 is coming in. Then you're going to have negative 10 milliamps coming out, which remember, that's actually 10 milliamps coming in. So we'll put plus 10 milliamps equals this 80 milliamps coming out, because that's going to be negative. So on the other side of the equal sign, it's going to be positive. All right, so I4 should, if we do that math real quick, should be 70 milliamps. Hopefully. There's I6, there's I4. Now let's do I4 again, but let's look at that node instead. So now we have I4 going out, 60 milliamps is coming in, 50 milliamps coming in, 40 milliamps going out. So let's keep the ins on one side of the equal sign, the outs on the other. So 60 milliamps plus 50 milliamps is going to equal I4 plus 40 milliamps. Let's do 40 milliamps plus I4, and hopefully I4 equals 70 here. So let's do some math. 60 plus 50, that is 110. 110 minus 40, when you subtract that over, just solving for I4, is going to equal 70. So 70 milliamps equals I4. Yep, they're the same. Wonderful. So that is an introduction to KCL, or Kirchhoff's current law. Next up will be the voltage law from Kirchhoff. Again, very useful tools. It's essential that you master these for any of your classes or if you're working with circuits at all. Thumbs up, share it with somebody, anyone. It's always appreciated when you stop by. Have a good day.